Welcome to the Fayetteville Robotics VEX IQ wheel channel video, the new version, updating our original video. Today we're going to look at building a wheel channel. The parts that we'll primarily use are those listed on the screen. We've got a bunch of different parts. This screen just lets you know what you'll need. Let's get on. So right off the bat, you can see we've got a few different things that we're going to be working with. We've got some 2x20 beams, a 2x8 beam. We do have a VEX IQ motor. We've got a pair of double 2-wide 2x2 double offset corner connectors, which is the official name for these guys right here. We've got some washers. We've got some spacers. We've got 3 of our standoff extenders. These are our standard standoff extenders, our 1-pitch extenders. We've got some 1x1 pins, 1x1 blue pins. We've got some rubber shaft collars. We've got some wheel hubs. And then in this particular build, we're going to be using some Omni wheels. So I've got a pair of those here. I also have some gears because this is going to be a geared wheel channel. So I've got 4 36-tooth gears and a single 48-tooth gear that we'll use. And then finally, I have 5 motor shafts. These are the long 2-inch motor shafts. These are the ones that have the green collar on them, 1/2 pitch in. And these are all the parts that we're going to use to build a wheel channel. So the first question we normally get is, well, what is a wheel channel and what is the point of it? But a wheel channel is this. It is simply a method of containing a pair of wheels connected to a motor, and usually they're connected either by gears or by chain within some plastic. And we do this because it creates a stable base to build our robot off of. And very specifically, it makes sure that our axles are supported on both sides by a piece of plastic and make sure everything is stable for you to build off of, and sort of creates the bottom of your platform for building a robot. So as we work through this today, we're going to talk about a whole bunch of different areas. And the first thing I want to talk about is something called slop. So this is an Omni wheel. Now for your build, you can use whatever you want. I just happen to be using Omni wheels. And I have an axle or a motor shaft. Now if I put this axle through, okay, from either side, I'm going to go ahead and do it from this side just so it's obvious. If I hold the axle and then I sort of bend the wheel, you can see that my wheel actually sort of tilts. Okay, it tilts on the shaft. It's not very tightly connected. And this is what we like to refer to as slop. You want your wheel to be steady and firm, so you have to find a way to get rid of the slop of an axle that passes through just one little piece of plastic. Now, to do that, what you need is you need something connected to this wheel so that this axle or motor shaft goes through 2 pieces of plastic. Now, the old way we used to do this was with one of these. This is a center lock 2x2 beam. So you notice it's got 4 round holes, but the center is square. It's an axle hole or a shaft hole. So that way you can put a motor shaft through it and it will not spin. It's why we call them center locks. They lock an axle to your plastic. And what we used to do is we used to take these and we'd take 4 1-pitch standoffs and we snap 4 of these standoffs into a center lock, just like this. Okay? And we would take this and we would insert it inside the wheel, push it in and snap it in, and then you'd have 2 pieces of plastic for the axle to go through. So the axle would go through one side, this would be snapped in, and it would come through the other, and it would basically create 2 points of connection between this axle or shaft and the wheel. Now, VEX has started selling a new part in the last few years called a wheel hub. It's this round piece of plastic. It's got the square axle and these sort of curved, it's sort of like a hemisphere. It's like half circle roughly. But if you take one of these, and I put 4 pins into this one, and you go ahead and attach it to your wheel, and you just want to make sure that it snaps in aligned on the inside of your wheel. You can sort of hear that snap. So now it's attached, and now when I take my motor shaft and slide it through, you can tell that I'm connected to the plastic here, and I'm connected to the plastic here. It creates that 2 points of connection, so my wheel no longer wiggles back and forth. And so that's the first new piece that we use, are these shaft adapters. Okay, so I'm going to take that and I'm going to drop one of those into both of my two Omni wheels, because that's going to make my life a little easier later on. But this, again, is just about creating stability in your wheels. So I'll set those aside. Next up, we're going to go ahead and we're going to start with one of our 2x20 beams. I'm going to slide some of these out of the way. 2x20 beam right here. So to build this today, we're going to start from this side and sort of work our way up. The only thing we're not going to attach right off the bat is the motor. So the first thing we want to do is we need to think about our spacing. And to do that, we have to think about our gears. Now in this case, I know I kind of want my wheels pretty much at the end, and I know I have to connect this beam to this beam in some way. So I'm going to grab my two 2x2 double connectors and pin them to the outside. This sort of gives me my maximum distance or edge for where my wheels can fit. So I can kind of set a wheel in, and just sort of get an idea of, how far forward can they get. Your positioning is going to depend on a couple of things. It'll depend on how long of a beam are you using and what size gears are you using. So as I look at this and I think about where my wheels can start, I'm going to go ahead, I'm going to start with a motor shaft, and I'm going to take the collared end and I'm going to put it in right there. So this is 4 pitches in, so 4 holes in, and that's where my first wheel is going to sit. And I'm going to go ahead and think about, what do I need on there? I need a gear, right? So the first thing I'm going to do is I'm going to take one of these washers. Okay, these are the super thin washers, and I'm going to drop it onto that motor shaft. Now, for this is that we always want to make sure that there's a tiny little gap between the edge of our gear and our plastic, because we don't want anything rubbing. If things rub, they create friction, and when you create friction, well, things slow down or they don't turn correctly. So I'm going to drop this guy on here, and so I can see where it's positioned. And now, make it easy, I'm going to sort of line this up. Well, my gear is going to go here, so I know my next axle has to go here, which happens to be 2 spots over. And again, I'm going to add washer, and I can drop my next gear on as well. I'll do that again, sort of line it up. Where's it going to fit? Right there. I'll add again my washer onto that motor shaft. There we go. We've got 3 of those. Now I know that my motor is going to have to attach somewhere in here, so I'm going to go ahead and use my drive gear. Okay, in this case, it's a 48 tooth gear. And you'll notice when you line this up and say, well, if I want to line this up right here, if I look in through my axle shaft trying to find a matching hole in my beam, it can't line up on these bottoms. That's because this is a half pitch different than these gears here. So it's going to have to go in the center. So I line this up and I find out that, hey, the axle is going to go right into this center hole right here. And I'm going to do this, attach this motor shaft, but I'm going to do it slightly differently. Because I know that my motor is going to attach to this piece of the motor shaft, the one on the opposite side, I need this piece to stick out on the other side of the plastic. So I'm going to insert it from the bottom. This leaves just the tip of the axle sticking out for me to attach my motor later on. Drop that one on. And once again, I'm going to add my washer and my gear. And then finally, I've got one more gear I'm going to add. I can come back here, look at it. You should know by now, hopefully, that it's going to be just a couple of spots down. Add my washer and add my gear. Now, just to test it, we can go in and grab one of these gears and turn, and hopefully we'll notice that all of our gears are meshed properly and spinning. And this is also a good time to double check and make sure that when you're spinning one of these gears, that your end gears, okay, your output gears, spin in the same direction, because they do have to spin in the same direction so that your wheels will turn together, forwards or backwards. You don't want them to turn towards each other. Okay, so you want to make sure that you have an odd number of gears is the key to that right there. So now that I've got those on, I have to think about how am I going to space this out? And it really is all about thinking about how we're going to space out each piece so that it's even on both sides. So we'll start out with some of our 0.25 pitch spacers. These are the only legal spacers for VEX IQ. So they're 0.25 pitch. And I'm going to go ahead and I'm going to add 1, 2, 3 to this end one before I add a wheel. This gives me spacers coming up against this wheel hub. Line it up, slide it in, there we go. And I'm going to duplicate that over on this end. So we'll add 2 and 3 spacers here. And again, we'll add my wheel onto that axle. There we go. And again, you can always just double check, make sure everything's working, spin one of your wheels, make sure they're all spinning in the correct direction. Okay? So that works for our first bit, but we need to, again, space these out. And obviously these don't have a full wheel on them, so you have to sort of work about measuring. And so the first thing we're going to do is we're going to think about, well, we need to keep these gears in place. So we're going to start with these. These are the rubber shaft collars. And I'm going to put a rubber shaft collar on each of these 3 gears. Line those up right there. And you can see as it fell over, my wheels came off. Not a big deal. We'll just line those back up and drop them in. And the next thing we're going to do is we're going to look at this. So this is a standoff extender. It's designed to allow you to connect multiple standoffs to one another. So it's designed to do this. You snap it on one end of a standoff, and then you can snap in another standoff. That's what it's designed to do. But there's a bonus to it. Because it is hollow all the way through, you can also use these as wide spacers. So that's what we're going to do. I'm going to drop one onto each of these 3 center motor shafts to provide spacing. Now, why do I not just leave it empty? Well, because again, it's all about stability. I want this to be as solid as I can so nothing moves. Because again, if your gears move and slip out of alignment, well, then your drivetrain's not going to work and your robot's not going to move anywhere. So we'll do that, and we'll add another rubber shaft collar on the top spacers. So there we go. We've got sort of the first starting point, trying to keep everything as even as we can. Now, as we work and we look at this, we can tell right off the bat that these rubber shaft collars are not sticking out as far as this edge of the wheel. So we are going to have to extend that a little more. And to do that, we'll actually use a beam. Okay? In this case, we're going to go back to this 2x8 beam. So as I look at this, and again, this is by trial and error the first time you do it if you've never done these before, I want to make sure that my spacing is as close as I can. So I'm going to add one more spacer onto each of these central motor shafts. Okay? And then I can take this piece of plastic and just sort of line it up and see if I can figure out, well, where does it need to sit? Okay, I can lay it here, which does fit on my motor shafts, but you'll notice that this piece of plastic is not in line with my, so I need to make sure it does match up, which that really means is that I need to have them go through the same slots. So these have to go through the bottom, and this one will have to go through the center. And if I look at it, we should be about in the right spot. Now, right off the bat, you'll notice this axle doesn't stick out as far as these other 2. Why is that? Well, if you remember, this is our drive axle, and it has the motor shaft sticking out this side for us to attach our motor to. So it is going to be a little shorter. And again, pop this wheel back in place because it doesn't want to sit in place. Not a big deal. So we need to attach the other side of our wheel channel. This is our other 2x20 beam. But if all we did was slide this on, yeah, it would attach at the ends, but this piece of plastic, our 2x8 beam, would be very loose. So we need to add some pins. So I'm going to grab just a couple of these pins and just sort of take a guess as to where I want it. I might come in and put a couple of pins on the end over here, maybe put some pins sort of here, maybe grab a pin here and a pin there. You can put it kind of wherever you want. The positioning of these pins is really going to depend on what, if anything, you're going to attach to this side of your wheel channel. So you may have to adjust where these pins go based on what you're trying to attach this wheel channel to. So I can come back now, and the way I like to do this, I'll sort of hold it up vertically, and I'll snap down just one end, and then start lining up my pieces. So I need to line up, and it's not super easy right off the bat, but it sort of falls into place. And then push down to snap all of my pins in, including my end ones. Make sure everything's pushed down. My center pins are connected. I can flip it up, and this is the majority of our wheel channel. Right off the bat, I can test it, make sure all my wheels go in the right direction. If I set it down and run it, everything works together. Okay, if I run just one wheel, they all work together. Okay. Now, right off the bat, as I see this, I notice, well, what's going on? These are sliding because we didn't put in enough spacers. So let's go back and fix that. And that's one of the things I really want you to think about. You're always going to make mistakes, and that's fine. That's the point of robotics and student-led programs. Okay? We want you to make mistakes because you learn from mistakes rather than having somebody tell you what to do. So I'll pull that piece off. Obviously, this one just fell off because they're not attached really. Drop it back in place. And I know I need to add space out here on this edge. So in that case, I'm just going to go ahead. I'm going to grab a spacer apiece. Drop those on there. And hopefully that's going to be all I need. Let's take a look. Again, I'm going to drop this onto my motor shafts. Snap them into place. Let's see what happens here. Make sure everything's lined up. The bat, you can see these wheels don't move nearly as much. There's still a little bit of slop back and forth. Okay, just a tiny bit. You can see when I pull it one direction, it comes away. If I push it, it slides back. Now, is that going to kill me? No, but I think we can do a little better. So again, I'm going to come back and I'm going to fix the problem that I discovered as I go. So I'll pull this beam right back off, and I'm going to add one more washer. These are the super thin ones. I'm going to add a washer to each of those ends. There we go. Let's try this one more time. Slide down onto my motor shafts or my axles. Snap everything in. Make sure it's all good and tight. Everything seems to be rolling. It spins. And when I come look at this, if I try and pull back and forth, you notice now it does not move. Okay, it is steady. It's never going to unmesh from these gears, so we're stable there. So the final thing we have to do is add a motor. And because we set this up with our motor axle sticking out on this side, all we have to do is take our motor, and we're going to add some pins to our motor. How many you need to add depends on sort of how much power or torque you're working on. I would suggest never less than 4 pins. Okay, and what we'll do is I'm going to take this motor. I want it to sit like this on this one. So I'll sort of line it up so that the axle hole is lined up with my axle. Just lightly push, and then I'll spin this until it just snaps in. And then if you move your wheels, you should hear the motor against it. Motor sound, it means that everything is connected properly. But that's it. That's the basis of building a standard wheel channel. And when you build two of these, now you do have to mirror them. So obviously this one happens to be two the exact same side. I can't flip this one over and have it be perfect because it's laid out a little differently. So you have to mirror them properly, and you'll have to figure that out on your own. But once you build two of them, you can actually connect them and create a wheelbase. And when we talk about a wheelbase, what that is we'll take this wheel channel, we'll take a mirrored wheel channel, and find some way to connect them across. Okay, you might connect them across the front, you may connect them across the back. That's going to be up to you, and what do you find as the best way to connect across. Okay, and remember, when you think about it, there are lots of little modifications you can make to this. You don't want your motor to be like this. Maybe you need it to be vertical to create yourself more space. Okay? Maybe you need to turn it this way so that your cable comes out this direction. There are lots of little adjustments you can make. But this is sort of the core of building a moving robotics base, is the wheel channel that provides stability and a platform for you to build your robot on. Once again, there's the parts list for what we did today. And hopefully this has helped you learn a little bit about VexIQ wheel channels with Fayetteville Robotics.